Okay, hello everybody. For this second lecture for a class, we're going to be talking about mass extinctions and their relationship to humans. So, when I talk about a mass extinction, we're talking about a widespread and rapid decrease in the biodiversity of the Earth. Of course, geological history is full of mass extinctions, and those extinctions are related to processes of evolution. We could argue even that extinctions can be a event that trigger major changes. So they can spur things like the rise of mammals. When we talk about the Cretaceous extinction 65 million years ago, after that, we see the rise of Mammalia as a major major family of animals. But extinctions are partly explained due to evolution, where we have the pressures of selection causing animals to specialize to certain climates and habitats. They change slowly to better adapt to these climates through random mutations. Most of those mutations are negative, so most changes um, lead to increased weakness and death and such, but a few are positive and create advantages. But environmental change create new pressures which may end up hurting a creature that was first well adapted to a specific place as it becomes less adapted. So things we've been talking about, like climate change, increased cold or heat or whatever else. So that's the basic way these things work. And mass extinction are these sudden periods often in the history of the Earth where environmental conditions change in such a way that many creatures that used to be well adapted become poorly adapted to the environments they're in and struggle to survive. And certain types of creatures, often more generalist types, are better equipped to survive mass extinctions than very specialized animals and plants. So what are some of the major causes of extinctions? They can be extraterrestrial in nature. So things like meteor impacts, a meteor hitting the sun, or hitting the earth. There can be fluctuations or major fluctuations in the sun. This is certainly a long-term thing we have to worry about in several 100 million years as the sun matures and changes and outputs different levels of heat and such. Climate change, so all the different Milankovitch effects that we talked about before that cause shifts of cooling and heating in the earth. Those are things that can help to trigger extinctions at different scales. Volcanic eruptions also can cause extinctions, and even biological events. So the spread of species and some effects caused by species can cause large-scale extinctions. There are something like 6 or 7 major extinctions. There are 3 I'll mention briefly, since these are some of the biggest ones, and they're pretty cool geologically, so before humans. One of them was referred to as the Great Oxygenation Event that happened 2.3 billion years ago. So this is right at the beginning of, after the beginning of life, where all life is essentially bacterial. And up to this point, the atmosphere of the Earth was oxygen poor. It was relatively less dense than it is today. But the growth and spread of cyanobacteria that were absorbing carbon dioxide that was being given off by volcanoes and coming out of geological degradation and such, one of the major byproducts of this photosynthesis and absorption of carbon was oxygen. So when we think about the modern cycle of oxygen and carbon, we think about animals creating carbon and breathing oxygen, and plants absorbing carbon and creating oxygen. So the Great Oxygenation event 2.3 billion years ago was caused by these cyanobacteria that created all this oxygen. Now, we think oxygen is all great and dandy, and it's necessary for us to live. But back then, most single-celled organisms were not adapted to oxygen. It was actually poisonous to them. And this caused the die-off of a huge number of single-celled species. So we have this event where large amounts of single-celled cyanobacteria end up fundamentally transforming the earth forever and killing off a lot of previous life forms. So that's pretty cool. I mean, it's a mass extinction that actually led to environmental conditions that are conducive to us today. Another major extinction event is the Ordovician-Silurian extinction that happened about 450 to 440 million years ago. This is not a single event. It's a number of interrelated events, but during this period, over 80% of the biodiversity of the world went extinct. So 80% of species went extinct. This was a period where there were no land animals or plants yet. Everything lived in the oceans. It's believed that this was kicked off by a major period of global cooling and glaciation, and then following periods of sea level fall, combined with possibly some large-scale volcanic activity that further caused rapid decreases in temperature, have been argued to have caused large amounts of Ordovician wildlife to go extinct. And we can see these changes in climate by tracking different types of fossils in their cold water brachiopods. This is a brachiopod right here, this crustacean essentially that moved much farther south than they previously were. And it just believed that there are rapid changes in habitat and a decrease in habitats that led to lots of animals to go extinct. One of the most famous extinction events is the Jurassic Cretaceous extinction 65 million years ago. This is where a large meteor hit the Earth in the modern day Yucatan, near the modern day Yucatan Peninsula, and it caused the die-off of something like a large percentage of biodiversity and then all of the dinosaurs, or most of the dinosaurs. Of course, there's some ancestors of dinosaurs today, which are birds, but all the large dinosaurs die off, and we see the rise of mammals and such. This impact, it caused a large shock wave that affected an extended area around where the meteor first hit and instantly killed animals even several hundred miles away from the impact. But more importantly, globally, it caused dust clouds that blocked out the sun and decreased it negatively impacted plants and such, decreasing the food for dinosaurs for 5 or 6 years at least. So this event caused the die-off of most of the dinosaurs and all kinds of other animals as well. The extinctions we want to talk about today, though, are the more recent Holocene extinctions that happened within the last 100,000 years or so. And so at the beginning of the Holocene, we had we're talking about a period where temperatures were significantly colder than they are today. There are several peaks and troughs in terms of the ice age. The environment, of course, was cooler, more arid overall than it was today. And there were lots more grasslands and over larger areas and smaller forests and such. So the environment was significantly different in this time period. But this is also the time period where we see the spread of modern humans out of Africa into the rest of the world. And so modern humans evolved first over around 200,000 years ago, and but they really only make it out of Africa 70,000 years ago or so. There are other species that were living in Europe and Asia that are hominins. They weren't Homo sapiens per se, but there are things like Neanderthals. There's a new species that was identified only a few years ago called Denisovans, and they're identified by DNA. They're really cool. They're actually related to modern day Australians, which we'll get to in a second. And even possibly some Homo erectus that were in Europe and Asia. But modern humans really only spread out of Africa 70,000 years ago, as I was saying. And the they first go into Europe and Asia 60,000 years ago, or 60,000 years ago. They spread to Australia, and then around 20,000 years ago, they crossed the Bering Land Bridge and spread into the Americas. And we have more recent examples of migration that are caused by humans. The most recent examples are into Polynesia, so into the Polynesian islands and into New Zealand as well, which only happened. It only really finished happening about 800 years ago, even. We're talking about the last islands in Polynesia and New Zealand as well. Now, what's really interesting is that we have a coincidence. This is something people debate about, but we have a strong coincidence between when humans made it to different parts of the world and when major extinctions occurred. So there's a major extinction and megafauna specifically. So a megafauna are defined as animals that are larger than 40 kilograms, or it's larger than about 100 pounds or so. We have a major extinction that occurs in Australia around 50 to 40,000 years ago. We have a major extinction that occurs in North America around 20 to 8,000 years ago. We have a major extinction that occurs in the Pacific Islands, especially places like New Zealand, 800 years ago. And there's a debate back and forth about what explains each of these extinctions and what role, if any, humans had in each of these. So is this all a big coincidence, or are there specific local factors that caused the extinctions of these large creatures in these different environments? And when we talk about, so what are behind these events and what role, if any, did early humans have in causing extinctions? When we talk about modern humans, they are somewhat different than other hominins in Asia and Europe, though, as we'll see later, the scale of extinctions in Africa, Asia, and Europe are not nearly as extensive as they are for these megafauna elsewhere in the world. So one of the earliest of these large-scale extinctions that's worth talking about a bit is in Australia. In order to study these extinctions, an important archaeological tool that we use are different forms of dating. There are multiple ways that we can date. These typically rely on geological phenomena. So one type of dating is AMS carbon dating. It has strengths and weaknesses. And when we talk about all these dates, one of the major things to keep in mind is they usually come up with date ranges. So these are not ways, something like carbon dating, for example, is not a way for you to tell, July 14th, 3000 or 30,000 BC, this happened. They give you a date range. These dates are also only useful for specific ranges of time as well. So AMS carbon dating, for example, it only really works up to about 30,000 years ago, and it works best less than 10,000 years ago. But it gives us a date range. This depends on the sample, but nowadays we can do plus or minus 20,000 years. But when we talk about things that happened 100,000 years ago or so, for example, carbon dating isn't so useful. There are other types of dating, like optically stimulated luminescence, that has to do with how light excites certain elements. So there are actually crystals within a lot of dirt, and light excites the minerals in those crystals to certain positions. And when they're buried, they remain in these positions until they're hit with light again. And you can use this to date some things. There's date ranges with this, and we also have things like uranium series dating, which looks at isotopes of uranium and how they decay over time. So AMS carbon dating is looking at carbon and isotopes of carbon and how they decay. So isotopes are these unstable, chemically unstable variations where they're extra neutrons typically. And you're looking at how the stable rate of decay over time. The thing with uranium dating, it goes back farther in time. but the date ranges that we have are larger. So instead of 20 years, we're talking about 1,000 years sometimes with uranium series dating. And the other thing we have to keep in mind is, what are we dating with all of this? So things like carbon dating, you can use carbon, you can use wood, you can use bone sometimes, but we're not always dating the things themselves that we want to date. Sometimes we're dating things surrounding those things. This is the same with all of these. So we're dating the level of, with thermoluminescence, we might be, or with optically stimulated thermoluminescence, we might be dating soil levels that are covering things that we want to date. Or with carbon dating, we might not be able to date the stone tools themselves with carbon dating, but we might find pieces of charred wood at the same levels as where we found the carbon, or we might find a piece of bone or shell or something like that. With uranium, there are only going to be certain stones or certain elements that have uranium, and so that's going to limit us as well. And also we have to consider how common are the things that we're trying to date, how common are those samples. When we talk about fossils, and even when we talk about early human sites, these are not, these are only a tiny fraction of these creatures that once existed. So for example, when we're talking about Australia, there's this creature called the Diprotodon. It existed for over 100,000 years. We only have 20 samples known of it. So it's hard to precisely date exactly when it was extinct based on that. So when we think about dating both when humans arrive certain places and when animals become extinct, those are big caveats to consider. So we're doing our best with what we have, but of course, these are relatively low resolution images that we're producing ultimately due to these limitations of both the dating techniques and these small samples that we're looking at. And they're also, these are imperfect guesses. So we're making granular, low resolution guesses. Now, what we can say about Australia 60,000 years ago is it was quite different than it is today. So Australia and New Guinea were part of one continent, and this is because sea levels were lower, and this was called Sahul. And Southeast Asia was also significantly larger than it was. So the environment was wetter in the Sahul than it is today. And probably at first, at least, it was more, it was richer, it was better. But there are all kinds of specialized marsupial megafauna in Australia around 60,000 years ago. So we had a marsupial lion, the Thylacoleo carnifex. He was the apex predator of the Sahul. There were kangaroos that are larger than are present today. So giant kangaroos, these diprotodons, which are as tall as humans, quite large, four-legged, grazing marsupials. There were giant reptiles like Varanus priscus that puts modern-day Komodo dragons to shame, and large birds like Genyornis newtoni that were as tall as people and roamed Australia. And of course, the marsupial line that I mentioned. Now, also around 60,000 to 50,000 years ago, we have evidence of the first migrations of humans into Australia. These were people that were migrating out of Southeast Asia. They're modern humans that likely mixed with other hominids. And this is common, and we have examples of this in Europe as well. So Europeans are related to Neanderthals. And it turns out that a lot of modern day New Guineans and modern day Aborigines are related to Denisovans. And this is based on DNA tests. There seem to be mixes between modern humans and Denisovans. Majority of DNA material, of course, are modern human, and we're talking about maybe 5% or so. But these people, they migrated out of Southeast Asia, and we have we can say that the distance between Australia and Southeast Asia is significantly less than than it is today. And it was much easier to make this crossing. But this is actually, in a fascinating way, our best indirect evidence there is for the earliest ocean-going boats. So the earliest sailing. So we don't have any of their boats preserved today. Wooden boats don't preserve well for hundreds of years, let alone 50,000 years. But people must have crossed somehow. And there's a lot of debate whether this was a purposeful happening or this was somebody was blown off course, they were fishing or something like that. But people were able to cross the straits into the Sahul, and we have a number of evidence of these early peoples. So DNA analyses, there's something called the genetic clock, and we can actually look at rates of mutation and compare populations to suggest when they divided, and differences between some Southeast Asian populations and New Guinean and Australian populations suggest a division around 60,000 years ago. So this is a new and exciting type of evidence that's used to look at migration. But we also have archaeological evidence. Now, dating of some of these sites is difficult. As I said, often cases for the earliest sites or for the earliest sites, there aren't skeletons themselves necessarily, and there's not material you can directly date. But using things like uranium dating, it's been possible to date early sites like the Majadebe rock shelter to between 65,000 and 50,000 years ago. And they find things like scrapers and these lithic tools. We can tell that they're tools because they're cryptocrystalline rocks that were hit together and in ways that created blades and edges. And we also find things like ochre that was probably used for body paints at these sites. So we find early artifacts first that suggests humans are there, these simple stone tools and things like ochre. And it's only around 40,000 years ago that we find the first human remains in Australia. And the first skeletons found are at a place called Nungo Lake. It dates to about 40,000 years ago. This is was now a dried up lake bed, but this person was found buried there with stone tools and such around them. So we can say that between 60,000 and 40,000 years ago, people were coming into Australia, and they're coming into the north first. They're spreading out and by 40,000 years ago, they're coming to more central southern areas like Lake Mungo, and making tools and such. Now, by 40,000 years ago, 16 of the 17 types of megafauna over 40 kilograms were extinct in Australia. So what is number 17 that survived? There are these red kangaroos here that are quite large, over 100 pounds. But all these other things, so the marsupial lions, the diprotodons, the large birds, the huge lizards, all of these things were extinct. Now the question is, what caused them to go extinct? And there are different theories. One of them is an overkill theory, that humans hunted these animals. They weren't used to humans. They didn't know to be afraid of them necessarily. They didn't evolve along with them. And so they were easy to hunt, easy to kill, and humans killed them off. There are people that push back against this, though, and suggest that climate change and aridification may have also stressed these populations and caused them to go extinct. And there's some people who argue that it was a 1-2 punch. It was a combination of the two. So what's the argument for overkill and the limitations of overkill? There's that chronological coincidence. So why are these animals going extinct right when humans show up? And there's evidence that there's some stability, especially at the beginning of this period in terms of the climate. This period was not at its beginning a period of major changes, though it seems like aridity happens later on. And the other thing a lot of people argue against climate change is that there have been all of these oscillations that happened in the past. These were not new species in Australia. They existed for hundreds of thousands, if not, several million years. And they dealt with cooling and warming and expansion and contraction of habitats before. So this was not the first time they had to deal with this. And so why is it, so what was so special about this 60 to 40,000 year period that caused them to go extinct then when they may have survived earlier? Now there is a period of overlap, maybe as long as 13,000 years for some of these creatures where they're living alongside. So the diprotodons, we find fossils, 30,000-year-old fossils of diprotodons in certain areas, suggesting that there's some overlap between when humans are there and when diprotodons are there. So it wasn't necessarily like humans' arrival caused everything to die out right away. Now, when we think about overkill, the other thing that's worth noting is the distinct lack of butchery or kill sites, or referred to as kill sites. We don't have any kill sites for these megafauna. We do have examples of broken eggs for these large birds. They're these Geniornis newtoni, that have been dated and may have relate to humans. They may have been, they may be natural, or this may be human caused, humans harvesting and breaking these eggs. But so we can't, there's not a smoking gun, or a smoking boomerang, we could say, for this overkill. But again, what I'd point out is fossils are rare. Megafauna finds are rare. Human skeletal finds are rare. This is, less than 0.1% of these past populations. And just because we don't find all these kill sites doesn't necessarily mean that they didn't exist. It's just maybe they're not preserved, or maybe they're in geological strata that we haven't encountered yet. So an absence of evidence does not make a lack of an event occurring. That's a basic thought in archaeology. Now, we do have evidence for aridification. Specifically, there are lots of small lakes that dry up in central Australia as deserts expand. We see dune formation occurring in areas where dunes didn't previously exist. And we also see more limited distribution for forest creatures than previously. But again, that question is, was aridification enough to cause these mass extinctions on its own? Or does this coincidence of humans showing up, does this speak to overkill, or a mix of, 1-2 punch? Environment degrades and there's stress from humans as well. So on its own, the case of Australia, we can kind of, we can go either way, I'd say. I might be convinced by climate change. I might not, if we were thinking about Australia on its own. But coincidences keep growing as we move out of Australia into other parts of the world. When we talk about the Americas, this was an area that 20,000 years ago, so 20,000 years ago to 8,000 years ago, we have mass extinctions there. Not 40,000 years ago or 60 to 40,000 years ago, like in Australia. So if we're talking about climate then for Australia, it's a local thing that had more impact in Australia than it would have in the Americas. That's one thing to think about. But in the Americas, we have a major extinction event 20,000 years ago to about 8,000 years ago, where we see large numbers of megafauna killed off. And of course, the climate is different then than it is today. It's cooler 20,000 years ago, and there's warming that happens as we move past 12,000 years ago to last 2,000 years, where there's a significant warming event. So over this period, so from uh, 20,000 years ago to before 20,000 years ago, we could say there are over 131 genres of megafauna in the Americas. They're greater than 40 kilograms. There are things like glyptodons. These are like giant armadillos. So they're little, small tank size, not as big as dinosaurs, but they're these giant armadillos. They're American lions. They're dire wolves. So this is not just Game of Thrones. Dire wolves once roamed North America. And in South America, we have apex predators like smilodons. They're kind of like saber-toothed tigers. There are giant ground sloths that are 30 feet tall. There are camels and horses and all kinds of things. There are over 130 of these species. Now, also around between 24 and 12,000 years ago, we have the earliest evidence of people coming to the Americas. These were people that are of they're from Northern Asia, not modern Native American populations are most closely related to modern day Siberians and Northern Asians generally. And there are multiple ideas of how they came. So it's believed that they crossed a natural land bridge called Beringia, but there are debates about whether they went along the coast to rapidly populate the Americas or they went through an ice-free corridor. Now, I think the preponderance of evidence suggests the coastal route because of sites like Monte Verde, which was inhabited before the ice-free corridor opened up. So this has pushed back our dates. It's a site in modern day Chile where they found a town. It's a waterlogged town, so they found wooden artifacts and lithics and such. And there's lots of wood to date. It dates back 14,500 years ago. But there are things like post holes and coprolites, which is human waste, so feces, and the remains of seeds and things like that as well. But this site is so important because it tells us people were in the Americas earlier than we previously thought, even as early as 20,000 years ago, before the ice-free corridor opens up that I talked about here, suggesting they're coming along along the coasts. And genetic evidence also suggests that American populations are diverging, 25 to 20,000 years ago from East Asian populations. Now, by 80,000 years ago, 45 of 61 North American genre are extinct. So things like the Western horse in Colombia, mammoths, woolly mammoths, and mastodons, and all of these things. And in South America, these ground sloths and camels and the smilodon. And when we look at the timing of all of these things, the arrival of humans into the Americas coincides with declines in population of all these major megafauna. And so people, again, when they see this, there are debates, and you'll read two sides of this debate, Martin and Meltzer and Grayson. But there are people that argue, this is quite a coincidence. What's going on? And this coincidence is pretty great. Now, we don't have lots of evidence of mass killings of megafauna. We do have some mammoth kill sites. There's 7 or 8 of them I can think of off the top of my head. A famous one is the Naco mammoth kill site. It's about 8,000 years ago or so, if I remember correctly. But there's not a lot of these mass graves of mammoths per se, where there are lithic points in their ribs that are smoking guns. But we see this drastic decline. Now, some people argue that climate change is responsible for this, not human hunting. And one thing we definitely do see is we see the contraction of grasslands as the area starts to warm up. And a lot of species like the mammoths and the camels and such, they did the best in grasslands and they weren't necessarily suited for forests, at least in North America. We have a different situation in South America. But yeah, and we have the same sort of arguments though. This isn't the first time that there's been a warming or a cooling period. There are multiple of these periods over the last couple of million years. Many of these species were existed for hundreds of thousands, if not millions of years. So what was so special about this cooling event that happened in 20,000, 20,000 to 8,000 years ago, or the warming event, I should say, that kill off these animals? Why did previous warming events do this? And again, what's special about this in North America, where there's earlier events in Australia were having some similar effects in this region. So some people argue overkill due to that coincidence, and there are others that argue that climate change stressed these populations. And you can also take the nuanced, mixed view of this. So what was so special about modern humans? This is something I don't have slides for per se, but it's really worth mentioning and thinking about. And something I should have added before I started recording this. What's so special about modern humans versus other hominins? The thing about modern humans is we were able to create tools that were out of a greater variety of materials that were much more efficient. So whether it be clothing that let us populate more extreme environments, or projectile points with bows and arrows, or were thrown with atlatls or fish hooks and all these things. These tools, they allowed us to more intensively harvest both plants and animals than previous Neanderthals or Denisovans or Homo erectus even. And so humans were just more efficient at these sorts of things. And when we talk about the Americas and when we talk about Australia as well, we need to remember that these were areas that were not populated by earlier humans as well. Now, the other thing to remember about why humans may have been uniquely capable of causing mass extinctions in these areas is local fauna was not, they did not evolve along with humans. They maybe didn't have the instincts to run that fauna in Europe, Asia, and Africa especially may have had when dealing with hominids. So we have these highly efficient, technologically capable species expanding into areas where local creatures are not, they're not adapted to or used to dealing with these. And so a lot of people argue this is a recipe for massive extinctions. And of course, when we talk about these extinctions, there's a lot of knock-on environmental effects as well. When you get rid of certain species, they have effects on vegetation, which have effects on environment, and all these things can cause, sometimes that can cause major degradations and other things. Now, some of the clearest cases of human-caused extinctions come from islands. So one of the better cases or more interesting cases we'll talk about in detail is New Zealand, but there are other island examples. So Hawaii, when Hawaii is colonized, other Pacific islands, even Easter Island, have similar situations where local flora and fauna are affected by human colonization. Now, what's interesting about New Zealand is they're relatively large islands that had some megafauna and some greater diversity. Now, humans only really make it to New Zealand around 1180. They're Polynesians that trek to New Zealand on ocean-going canoes. So the modern-day Maori, the inhabitants of New Zealand, are descendants of these populations. And New Zealand was one of the later islands to be, one of the more distant islands to be colonized. And the Polynesians, they were amazing sailors. They had great seafaring technology, and they brought all of these crops, so things like taro and cassava, with them. And they also brought animals, so things like pigs and chickens, and they also brought rats, which had a huge negative effect on smaller, on all kinds of creatures, but smaller creatures, and some plants as well. But before the arrival of Polynesians, there were several different species of megafauna in New Zealand. These were mainly birds. So there were humongous eagles called Haast eagles. They had wingspans that are twice the wingspan of of people. I think they had 30-foot wingspans or something like that. And most notably, there were several different species of moa. So moa were these giant birds. They're kind of like emus today. These were taller than people. Now, all I have to say is, can you imagine KFC today if Moa were still around? Can you imagine those drumsticks and all these things? These were giant birds that were indigenous to the North and South Island of New Zealand. We have evidence that these birds were heavily exploited by Maori peoples when they first settled. And so they were doing things like making fish hooks and making tools out of the bones. And they were, we find kill sites. And by 1300 AD, a couple hundred years after the colonization of New Zealand, moa are extinct. And once those moa go extinct, predators like the Haast eagles go extinct as well. Now, Pacific rats, they also cause all kinds of havoc for plants and smaller animals. And so another example of environmental change that's kind of cool, I'll mention briefly, is Easter Island. Easter Island and a number of other islands, people talk about people cutting down the last trees of Easter Island and this major environmental degradation. There have been new studies that suggest that rats might be possibly partially responsible for the disappearance of trees on these islands. They're actually eating the seeds of these trees before they can germinate. And it might not be that people were actively cutting down the last tree. It might be that rats were causing chaos as well. But when we talk about these events, they transform the environments, and in some ways they impoverish their environments in terms of food sources for humans, and they create all of these other changes as well. So large creatures like mastodons and mammoths, they had major effects in terms of the types of plants that were available and such, and their absence caused environmental changes. And of course, when we talk about all of this, it's relevant to extinctions and environmental change today. So that's why I consider these to be disasters, and they're human-caused disasters rather than necessary, or they may be. I mean, you can consider the evidence for yourself. I favor overkill just because of all the coincidences. And those coincidences, when we look at other areas of the world where humans had a longer presence, we do have mass extinction of megafauna in places like Europe, but it's less pronounced than it is in other parts of the world. And so people migrate into Europe about 40,000 years ago, and there are extinctions 35,000 to 10,000 years ago in the area. There are things like woolly mammoths, woolly rhinoceroses. So 21 of 37 genre, but there's significantly more genre that survive. This may be due to the fact that there's longer interactions. And also when people talk about those extinctions, they do also highlight climate changes and the rapid shifts of environments. And other large megafauna that went extinct were huge elk, so Irish elk and such. What's really interesting is when we look at Africa, we have a few megafaunal extinctions, but really it has the least number. Africa and Asia have the least number of megafaunal extinctions. Why is that? Why is it that there were climate events that really knock things out at certain times in Australia, and then at other times in North America, and other times maybe in Europe, but there's really no equivalent in Africa. Certainly when we talk about climate change, one of the big things in Africa is increasing and decreasing aridity that go along with climate change. They're not necessarily dealing with glaciers and ice and such, but certainly environments change quite a bit. But why is it that megafauna in Africa survive? And there's so many things like elephants and rhinoceroses and such. And another question we can ask is, why aren't there extinctions of marine megafauna? We don't see those extinctions going along with the terrestrial ones. And certainly they would have been impacted by climate change. And as we talked about when we talked about the Ordovician Silurian extinction, changing climate conditions can have major impacts on sea life as well. Now, a good modern example of this that I thought was pretty amazing in the news recently was there was an article about mussels in Canada, and it was so hot in Canada recently that in Vancouver and British Columbia, that large banks of mussels were actually cooked, and that's an example of of climate change causing extreme climate fluctuations causing large die-offs that might even lead to extinctions. So by themselves, we can look at Australia, we can look at North America, or we can look at Europe even. Not so much New Zealand, because I think there's a pretty good argument for human involvement there. But we can look at those and we can identify climate change and things that seem to, that may well have caused extinctions. But I think when we look at the overall trend, when we look at all of these coincidences together, there begins to be a more and more compelling case for the overkill hypothesis with this coincidental evidence, and for humans having a major part to play in the extinction of all of these animals. And again, we don't have as many kill sites as we want, but I point out again that things being preserved archaeologically and paleontologically is quite rare, actually. So we have a very fragmentary, incomplete picture. So that's something to think about. That's something to consider. And I think that there's a really strong coincidental argument to make that every time humans show up, there seem to be these extinctions, and these continue with the colonization of all these islands. There's similar extinctions in the Lesser and the Greater Antilles in the Caribbean, as they're colonized 3,000-4,000 years ago, and with New Zealand and Polynesia and Madagascar as well. There are these coincidences. And I think all of these, when we take them together, suggest that humans had significant capabilities to disrupt and drive extinct lots of animals in different ways. We had that in the past, and we're doing it today. So, a recent example of an almost extinction event were the bison in the 19th century, bison hunting. Within less than 100 years, we went from a population of 25 to 30 million bison to less than 100 in the wild. And those populations have significantly rebounded, but overhunting with repeating rifles and such, people were using bison skin for robes. They were doing all these things. These can cause rapid extinctions with modern technologies. And today as well, with shifting climate and increasing exploitation of different habitats and all of this, we have one of the larger scale extinctions that we've seen in the history of the Earth as well. So over 477 vertebrate species, or species with backbones, have gone extinct since 1900. And when we talk about microorganisms and small plants and animals, and insects, we really have no idea of how many things are going extinct. And of course, as I've alluded to before, maybe haven't explored as much as I should, these things can all have knock-on effects, and they can create feedback loops and create environmental changes that we don't really know the extent of. Another thing to point out, another area we see a lot less of than we understand less as the ocean, but it seems like we have major extinction events occurring there. So these are all things to consider, but killing off that these can be major disasters with negative impacts for humans because they can transform environments, and beyond that, they just degrade the beauty and the awe-inspiringness of the world as we know it. So that's it for this lecture. I'll talk to you all in our discussion.